Hello dear students, this is Pure Mathematics chapter 4. In this video we are going to discuss about section 4.2.3 which is about combinations. So in the previous videos you have learned about the permutations. So when there are n objects and we are taking r objects from a set of n objects, what are the number of permutations we have, and that is denoted by NPR. And now we go to the definition of combination. So let us look at this definition. A choice of R objects from a group of n objects without regard to order is called a combination of n objects taken R at a time. And the number of combinations of n objects taken R at a time is denoted by NCR and is given by the formula NCR is equal to n factorial divided by r factorial times n minus r factorial. In other words, NCR is equal to NPR divided by r factorial. So the meaning of this is there are n objects. So these are n objects and we are taking r objects, any r objects from this set of n objects, and when we are selecting these R objects, we are not taking the order into consideration. These R objects we are selecting may be in any order. So when we are not considering the order of these R objects which are selected from n objects, so that is called a combination, and the total number of combinations when we are selecting R objects from a set of n objects is denoted by this formula n factorial by r factorial times n minus r factorial. So here the selection is made without considering the order. That means it is simply a collection of r objects from a set of n objects. To understand this, let us look at an example in the next slide. So let us see this collection ABC. There are 3 objects, so n equal to 3, and we are interested in selection of 2 objects from these 3. So we are selecting 2 objects, so r is equal to 3 from this set of 3 objects. And while we are selecting this one, we are not taking into consideration the order. So 2 objects we are selecting, those 2 objects can be in any order. Order is not important. So these are the possible combinations. So what are the possible combinations of selection of 2 objects from these given 3 objects ABC? AB, this is a collection, and AC, 2 objects, and BC. So there are 3 collections of 2 objects. We are collecting 2 objects from the set of 3 objects, and those possible combinations are AB, one combination, AC, one combination, and BC, another combinations. So there are 3 different combinations we have. So when we are selecting R equal to 2 objects from a set of n equal to 3 objects, there are 3 combinations. So even in the formula, if we keep, this is denoted by NCR for finding the number of combinations, is given by the formula n factorial by r factorial times n minus r factorial. Here n is equal to 3. If we substitute n equal to 3, 3 factorial divided by r. R is equal to 2 here, 2 factorial, and n minus r is 3 minus 2, which is 1 factorial. And we know 3 factorial is product of numbers starting from 3 up to 1. So 3 times 2 times 1 is 3 factorial, and 2 factorial is 2 times 1, and 1 factorial is 1. So if you cancel 2 and 1, both numerator and denominator, then you will have the value 3. So the number of combinations is 3. That is what we are getting here. There are 3 possible combinations when we are selecting 2 objects from a set of n objects, which is 3, n equal to 3 here. Let us look at another example. Here A, B, C, D, four objects are given, n equal to 4, and we are interested in selecting two objects from this set of four objects. So n is 4 and we are selecting two objects, so r is equal to 2. Then what are the possible combinations when we are selecting two objects from this 4? What are the possible combinations? AB, you can select AB, two objects, or AC, or AD, or BC, or BD, or CD. So these are the total combinations that we have when we are selecting two objects from a set of four objects. When we are taking AB as a collection, we don't consider again BA, because AB is a collection without regard to order. This may be in any order, AB or BA, both are the same. So AB as a whole, we take one consideration, one collection. And AC, the order of A and C is not important. Two objects, A and C, or C and A, both are the same. Like that, there are 6 combinations when we are selecting two objects from a set of 4 objects. So if we put in this formula for combinations, NCR is denoted by this symbol, brackets, NR denoting NCR, n factorial divided by r factorial times n minus r factorial. Here n is 4, so 4 factorial divided by r is equal to 2 factorial, n minus r is 4 minus 2. 4 minus 2 is again 2 factorial. Now let us write the value of 4 factorial is 4 times 3 times 2 times 1, and 2 factorial is 2 times 1, 2 factorial is 2 times 1. And if we cancel 2 2s are 4, if we cancel with this 4, the numerator and denominator, we are left with 3 2s are 6. So there are 6 combinations when we are selecting two objects from a set of 4 objects. There are 4 given and we are selecting two objects. So when we are considering with combinations, the order is not important, simply a collection. So let us go to other examples here. Example 4.2.10. How many different ways there are to select a 3 people committee from a group of 30. So there is a group of 30 people and we have to select 3 people committee. Committee means the order is not important. Simply we need any 3 people without regard to order. That means you have to find the combinations. What are the combinations of 3 people from a set of 30 people? So here n is 30 and we are interested in a collection of 3. So r is equal to 3. So if we put in this formula NCR, n is 30, r is equal to 3. NCR formula we know, n factorial, that is 30 factorial, n is 30 divided by r factorial, r is 3 factorial times n minus r factorial, 30 minus 3. 30 minus 3 is 27 factorial. And if we expand this, 30 factorial is nothing but 30 times 29 times 28 times 27 factorial, and 3 factorial is 3 times 2 times 1, and we have 27 factorial. And if we cancel 27 factorial with the numerator, we have 27 factorial in the numerator as well as in the denominator. If we cancel that, we are left with 30 times 29 times 28 divided by 3 times 2 in the denominator. That gives 4060. So there are 4060 different ways of selecting a 3 people committee. So 3 people committee is how many committees we can select? 4060 committees we can form from a group of 30 people. And the next example 4.2.11, a professor wishes to choose 5 students from a class of 15 students. How many different groups of 5 students are possible? So there is a group of total 15 students and we are interested, the professor wishes to choose 5 students from this. So 5 students we have to select, and without regard to order, in any order. So n is here 15. There are total 15 students, and r is equal to 5 because the professor wishes to choose only r students from the 15 students. So n is 15, r is equal to 5. Again, if we put in this formula NCR, n factorial by r factorial times n minus r factorial. N factorial is 15 factorial divided by r factorial. R is 5, 5 factorial times n minus r. 15 minus 5 is 10. And if we expand 15 factorial, 5 factorial, and cancelling 10 factorial on numerator and denominator, the value of this is 1001. So how many different groups you can form therefore? 1001 different groups of 5 members or 5 students can be made from a class of 15 students. So all these are combination problems where there is no regard to the order. Order is not important. Without considering the order, simply we are selecting some group of objects or members from a given set of objects or members. So the next example 4.2.12. A committee is consisting of 14 men and 16 women. How many ways one may select exactly 6 women and 6 men? So there are 14 women, 14 men and 16 women, and we are interested in selection of 6 women. So from 16 women we are interested in selecting 6 women without regard to order. Order is not mentioned here, so we may select any 6 women from a given set of 16 women. Similarly, from a given set of 14 men, we wish to select 6 men. So any 6 men without regard to order. So if we look at this one, in how many ways you can select 6 men from a group of 14 men? It is a combination. So 14C6, that is the first one. 14C6, from 14 men we are selecting 6 men. And the number of ways of selecting 6 men from 14 men is 14C6 combinations. And the next one, we want to select 6 women from 16 women. Again, without regard to order, any 6 women we can select. Therefore, the combinations are 16C6. The number of combinations is 16C6. We are selecting 6 from 16 women. And together both we have to do. One is 6 men from 14 men. The second one is 6 women from 16 women. So both together, how it will happen? We use the product rule here. So the number of ways of selecting both 6 men from 14 men and 6 women from 16 women, both together is 14C6 times 16C6. So the first one is selection of 6 men from 14 men. The second one is selection of 6 women from 16 women. And for both to happen, you have to use the product rule. So the product of these two is 3003 times 8008, which gives us 224,048,024. So this is the number of ways of selecting 6 men from 14 men and 6 women from 16 women. Now we have one problem in the exercise of your material notes, material there. And the 9th problem in the exercise is this: how many ways are there to select 3 candidates from 8 equally qualified recent graduates in computer science to work at a company? So there are 8 equally qualified recent graduates. So n is equal to 8. all are equally qualified, and we want to select any three candidates without regard to order. We are just interested in selection of any three candidates because all are equally qualified. So the order is not important. So we go for the combinations. Here n is 8. There are total 8. And we are interested in selection of 3 candidates. So r equal to 3. And if we need the combinations, NCR is the formula. NCR is equal to n factorial divided by r factorial times n minus r factorial. That is equal to 8 factorial. N is 8 here and r is 3, and n minus r is 8 minus 3, which is 5. And if we expand 8 factorial and cancellation of 5 factorial with 5 factorial in the numerator, and then simplification gives the value 56. So 56 is the number of ways of selection of 3 candidates from a group of 8 candidates. So this is all about problems on the combination, and we use combinations whenever there is a selection of objects or members from a given set of objects or members without consideration of the order. Whenever the order is not important, we consider these combinations. This is the end of this topic, combinations.